Hey guys, this is Mr. Quinones on your first tutorial of how to use Carnegie Learning. Okay, so first off, go to your Carnegie Learning website. Remember to use Firefox. Okay, so hopefully you made a tab. I didn't make a tab. I thought I made a tab. I'm making one right now. Alright, so we want Carnegie Learning, and if it takes you to this page, this is the main website. You got to go to software login, and this is the one that I think you should make a tab. What do you call it? A bookmark. I put a little star. I don't know where it saves it, but we'll find out. Alright, type in your ID and password, and this is important. I've been exploring the two different softwares that are on here. And I found out that the light version is pretty nice. I think we should use that one instead. Seems to be less trouble. But it did take a long time to log in. So I'm going to pause it while it logs in, because I have a really slow internet connection. My cell phone is the internet right now. So I'm going to pause it real quick and let it load up. Alright, so here's the three. We have the prime, the light, and then whatever this is. I don't know. We'll test that out later. Let's do the light. Carnegie Tutor light. So I'll click on that bad boy, and I'm going to say open the tutor, open file. Yeah, let's use the web Java. Maybe I should save that file. That'd be interesting. I know what it does with that one. I think we just open it with Java. Should work. It looks like it's downloading the file. Yeah, look at that. Downloading Carnegie Tutor. Let me run this one. Alright, it brings up this question. Yes, do not show yet. Yes, don't run it. And there it goes. Alright, so then next window that came up was to choose them. I'm going to use this one, linear and exponential relationships. Let's start with that one, all of us. That'll be our start. Able to launch. What? I think it might have been from the previous question. So, looks like it's running. And sorry guys about the slow connection. In the meantime, how about we look up some jokes? What's running this thing? Let's see. Funny teacher jokes. Come back to here. Just take a look in here if it's running. Oh, here's some good jokes. Let me take a look to see if it's open. Okay. You already logged in. Okay. Yeah. All right. All right. So here's our list. Let's do this together, because the most important thing of this software is you can't just jump in and start clicking away. You have to read, you have to understand, you have to really take time to see what it is you're supposed to learn. This program, you're not going to be able just to go click, click, click. I don't know, I don't want to read anything. So I'm going to pretend I'm you right now. I'm like, okay, so we're in, let's read everything here. Okay, we're in section 1 of 3 of sequences. So there's 3 sections. Glossary, user assistance, hi me, and then there's something that says go to problems. Look at that right here. So alright, so a lot of you are just going to jump in and let's go to the problems without reading it. That's a big no, don't do that. You're just going to waste your time trying to figure it out. Alright, let's read something about sequences. Describe the pattern of a sequence in a sequence. A sequence is a pattern involving an ordered arrangement of numbers, geometric figures, letters, or other objects. Okay, so you have to understand this. If you don't understand that, read it again. A sequence is a pattern involving an ordered arrangement of numbers, geometric figures, letters, or objects. Alright, this is blue. Let's click on this. See what it says. Probably going to give us a definition. Okay, so we're kind of exploring here a little bit. So look, there's all the different terminology, other words. And a scale drawing. So it might have taken us to it, but I clicked on another one. And there it is, the definition. Here's an example. 10, 20, 30, 40 is a sequence of numbers. The number of triangles is a sequence of objects. Here's 1, here's 3. There's a comma separating those. It's kind of growing. Alright. A term of a sequence is the individual number, figure, or letter. Okay, an ellipsis is used to show that a sequence continues on forever. Alright, so this means the sequence goes forever. So here's a sequence of numbers: 1, 3, 5, 7, 9. It looks like they're all odd numbers, and they're going up by 2's. Okay, pretty easy. That's what it says here: 1, 2, 3. Now, see how we're taking time to read. This is what you have to do. Alright, in this sequence, 1 is the first term. Okay, that's the first term. 3 is the second term. See the little figure right here? It's hard to tell, but it's a little comma, I think. 5 is the third term, and so on. And here's the 3 little dots, which means it goes forever. To describe the pattern in a sequence, you would say that the constant 2 is added to each term to produce the next term. Constant 2, it means it's adding 2 every time. You need at least 3 terms to determine the pattern in a sequence. So look at that, you need at least 3. Okay, you can't have 2, only 3 is the minimum. Alright. So now we read some more. So now we understand what a sequence is. Below are descriptions of some common patterns seen in sequences. Each term of the sequence is equal to the previous term plus or minus a constant. So each term is equal to the last one, the one before it, a plus or minus a certain number. Okay. Each term of the sequence is equal to the previous term multiplied by or divided by non-zero. It can't be 0, because if it's multiplied by 0, it becomes 0. Each term of the sequence is equal to the sum of the previous 2 terms. Oh, that's interesting. Each term of the sequence is equal to the previous term plus a regularly increasing amount. Oh, I see. Alright. For each example, describe the pattern. Then determine the next 2 terms in the sequence. Okay, 9, 7.5, 6. So it looks like if you had $9 and then you had $7.50, then that means you lost $1.50. And then $7.50 to 6, hey, look, you lost another $1.50. So all of these are going down by $1.50, or 1.5 if you want. Let's look at B. 1/4, 1/2, 1. So if you had a quarter, and then you had a half, and then you had 1, looks like it's doubling. So 1/4, double that is half, double that is 1. So the next number would probably be 2, and then 4, and 8. Look at this one: 0, 1, 1, 2, 3, 4. So this one went up by 1, this one went up by 0, this one went up by 1, and 2. Well, I don't know. That one's kind of tricky, because it went up by 1, then nothing. I don't know. Maybe that has a pattern, maybe it's not a pattern. Or maybe this number, the third one, is the addition of those 2. The second number is the addition of those 2. 3, that's the addition of these 2. That makes sense. And 5 is the addition of, oh, there's the pattern right there. Weird. I would have never figured that out just because I read this one right here. Each term of the sequence is equal to the previous term plus a regular increase in, no, not that one. This one right here. Each term is equal to the sum of the previous two terms. That's it right there. Alright, next. 16, 10, 5. So it's going down by 4. And we're going down by 5. Going down by 4. 4, 5, 4, 3. That's a tricky one. I can't figure that one out right off the top of my head. Come back to that one. Alright, let's see. Look at A. Alright, A. You can see that the terms of sequence are decreasing. Okay, so that's the one that we did, A. Right there. Each term. So this is kind of the example. See, we just figured out, we'll kind of do this on our own, but here is the actual worked out example. I was curious on the one that we got stuck on, and we means me. Maybe you got it already, I don't know. D. Okay. Here's C. Hey, we figured that one out, adding the two terms. D. You can see that the term and the sequence are decreasing. Yeah, we got that. Determine the change pattern. Okay, this one was minus 6. Minus 6, minus 5, minus 4, minus 3. Now, the difference between these two is add 1. This one is adding 1 to, not to these numbers, but to the difference we're going to subtract it by. Genius. Okay. Write a recursive formula for a sequence. Okay. Alright, so what I'm trying to do here is to demonstrate how it is you're supposed to analyze and understand this. Okay. I'm going to run out of time on my recording, but this is how you do it. You have to go through this. You can't just jump to the problems. If you jump to the problems, you're not going to know what to do. So here is a problem right here. This is what actually you're going to be doing. But it's really hard to do this without actually going through the lesson. Okay? So what I was looking for before is a lesson. Alright, so here's a problem that we're going to be kind of looking at just to get rolling on here. First question is, first classify the sequence, then describe the sequence and calculate the next two terms. So in this page right here, you can get right to it, but it's going to be hard. What do you mean classify the item? I don't really know what that means. Okay, you can take a hint. Okay, but this is not really how you want to be learning this. This young lady says, what type of sequence is this? I don't know what kind of sequence this is. I don't even know there's names for sequences. So what I should do is go back to the lesson and understand the whole thing. The sequence, the terms of the sequence, arithmetic sequence. So when it's asking what type, it might be this thing, arithmetic, or is it geometric? I don't know what those terms mean. So it takes a lot of work here. What I recommend you do is get a notebook and write down some notes. What is an arithmetic sequence? What is a common difference? What is a geometric sequence? What's a common ratio? So how are you going to know that? Well, you can click on it and read and kind of skip all this stuff, but that would be wasting time. Let's read this. An arithmetic sequence is a sequence of numbers in which the difference between any two of the consecutive terms is a constant. That's an arithmetic sequence. So it means that the difference between the two is always the same number. Okay? So I suggest you have a notebook and you're going through this, you're taking really good notes, and then so it takes a lot of work. And when you get to the bottom, they have an example. So you do the examples. This might take like maybe an hour to do all this. Okay, going through this very carefully. And then after that, you can go to the problems. Okay, I'm going to pause recording here, and I want you guys to explore and experiment with only this page. keep us your feedback. Thank you.